In this video, we're going to take a look at what the leading coefficient does to the end behavior of the graph. So again, this is a slide from your vocab sheet, so you can either follow along on your vocab sheet and make extra notes or just listen as I give you some information. If n is odd, the leading power or the degree of the function is odd, and this first one right here, if the leading coefficient, that's what this part means right here, that a sub n is that's the leading coefficient, is greater than 0, meaning positive, the graph will look like your typical snake function. There may be some extra bumps in the middle, but what the leading coefficient test tells us is what it does at the end of the graph, meaning when x is very large or when x is very small, approaching negative infinity. So it will fall to the left and rise to the right. Again, if n is odd, you've got that highest power is odd, but the leading coefficient is negative. It'll flip it around and it will rise to the left and fall to the right. If n is even, the highest power of the function is even, and your leading coefficient is positive, your graph will open up, or you can think about it rising to the left and rising to the right. And then finally, if that leading coefficient is negative with the highest power even, it'll open down or fall to the left and fall to the right. I'm going to show you a way that we write that in kind of calculus notation to get you used to what you might be writing for next year. So when we're identifying the end behavior, so what we start with is we say as x approaches, that's what this arrow means, negative infinity. So what you want to think about is what the graph is doing off to the left as x is very small. So now here's where we're going to look at the function. We've got the highest power is odd and the leading coefficient is negative. So you may want to sketch a shape of, or a quick sketch of the graph. It's rising to the left. So as x approaches negative infinity, f of x, or the function, or the y values, approach positive infinity. What that means is that the graph is going up towards the high positive numbers. So then we're going to say, on the other hand, as x approaches positive infinity, so as your x values get very large positively, or off to the right, what is happening with the graph, the function, the y values, are decreasing or approaching negative infinity. So again, to read these for you, because I'm sure that these statements are new, as x approaches positive infinity, f of x approaches negative infinity, and we're seeing that right here as the graph decreases off to the right. Taking a look at another example, we've got the highest power is even and the leading coefficient is positive. So that will look like a graph opening up. It is a fourth power, so there might be a W, there might be some wiggles in the middle, but again, we're not concerned with what's happening in the middle of the graph, we're identifying the end behavior. So as x approaches negative infinity, what's happening off to the left? The function or the y values are increasing or approaching positive infinity. And finally, for this one, as x approaches positive infinity, the function or the y values are again increasing off to the right, so f of x approaches positive infinity as well.